So this morning I'm going to record a video for section 2.2. Everything in section 2.2 is supposed to be reviewed, but it may or may not feel like that. Do a lot of line stuff in both brief calculus and traditional calculus. So this is an important section because you'll see it again if you have to take more math, and a lot of you have to take more math. So this is a good section to just get down really well. When I first studied lines many years ago, yeah, I probably got an A on the test over the topic, but I really didn't understand the material, and I don't know that you completely understand something until maybe you teach it, or if you've seen it, if you see it maybe for the fourth or fifth time. So hopefully this might be the third or fourth time that you're seeing lines, and all of a sudden it starts to sink in a little bit. So the first 6 problems ask me to plot the points on a graph and then find the distance. There's going to be multiple ways to answer these to get to the answer, but there's only going to be one answer. The answer is a number that measures how far the points are apart. And what a cruddy first problem. I probably did this for a reason. I did this so it came out nice. So let me do what I said. I'm going to graph the points. So the first point is the point 1, 2. So I'll just make a dot for it. And the second point is the point 4, 14. I'm going to be lazy on my y-axis. I'm just going to mark the number 14 and not make little tick marks and show every number between. So I've plotted the points. I want to find this distance. I want to measure how long this is, and I'm just going to measure it in units. I'm not going to call this inches or centimeters. I'm just going to call this line is so many units long. And there's multiple ways to do that. There's a formula that eventually we're going to need to remember, but we can bypass the formula, and that might not be a bad thing to do. So first I'll do this the non-formula way. The non-formula way is to make a right triangle from my picture. To do that, I'm going to draw a line from the bottom point parallel to the x-axis till I get over to the 4, and then I'll draw a line parallel to the y-axis. Now I've drawn a right triangle. The side that I'm trying to measure is the hypotenuse of the right triangle because it's opposite the right angle. So I'm going to call it the letter C. And the other sides, I'm going to call one an A and another a B. And it doesn't really matter which, but I'll call this side A and that B. I'm going to use the formula a squared plus b squared equals c squared to figure out what c is. And in order to use the formula, I need values for a and b. I need to know that this point right here is the point 4, 2. A is the distance between this point and that point, and it's just the distance between 1 and 4, so it's just 1, 2, 3. So in my drawing here, the A side is 3 units long. It's the difference between the 4 and the 1. The B side is the difference between this 14 and that 2. So the distance of this side, the difference between 14 and 2, is 12. And now I'm going to plug the numbers into the formula and figure out what C is. And I brought a calculator this morning just in case I need it. So again, I drew the picture as I was asked to draw, made a triangle, figured out the length of each of the sides, and that's really just done by subtracting. For this A, I'm subtracting the x coordinates of the point that I was given and the point that I constructed and got 3. And then for the B, I subtracted the y coordinates of the points the point that I was given and the point that I constructed in the triangle. I'll just use the formula. So a squared is going to be 3 squared. B squared is going to be 12 squared. That's going to equal c squared. I could use my calculator to do 3 squared, but I can't. I don't need that. 3 squared is 3 times 3, which is 9. You may need your calculator for 12 squared. 12 squared is 144. And then c squared is just c squared. Now I'm going to add the 144 and the 9 on the left side and get 153. So I get 153 as c squared. And then usually when you solve a problem like this, you do square root plus or minus the square root. But because c represents a distance, which is a physical quantity, and distances only have positive lengths, I'm just going to take the square root of both sides and not do plus or minus, because c can't be a negative number, it's a positive number. So I'm going to cross out on the right side, because when you take the square root of a number, or of something squared, the square root symbol crosses out the square. And now I'm going to look at the square root of 153. I don't believe that's a very nice number. If I do the square root of 153 on my calculator tells me it's 12.36. I'm not going to give a decimal answer unless I want a decimal answer, but for a square root, I need to see if that square root is a reducible square root. And so I'm going to see if I could write 153 as something better. For instance, just to refresh your memory, if I got an answer like the square root of 18, which would also be a decimal, I could represent the square root of 18 differently in a non-decimal form by breaking up the 18 into 9 times 2, and I can rewrite the square root of 18 as 3 times the square root of 2. So I'm going to see if I can do that with the 153. I have a calculator that does this real nicely, so I'm going to maybe go get it here in a second, and there'll be this pause on the video, which is not technically good. But in order to work on the 153 to see if it's reducible, I'm going to need to factor 153. 3 goes into 153 because if I add up the digits 1, 5, and 3, I get 9. And it's going to be 3 times 51. And 3 goes into 51. 3 times 51 is 3 times 17. And 17 is prime. So the prime factoring for 153 is 3 times 3 times 17. That means the square root of 153 can be rewritten as the square root of 9 times the square root of 17. Square root of 9 being 3. Now I can answer my question in the best way possible. So C is the distance between the points. And I'm going to say it's 3 times the square root of 17. I'm going to run and get a calculator. If you have a second, you can work on problem 1, which probably won't have such an unpleasant answer. Or you can fast forward, and I'll be back in hopefully a minute or two. All right, so dug out this calculator. For a non-graphing calculator, this calculator is completely awesome. This is a Casio FX115 ES Plus. This calculator, in some sense, it's better than my TI-84. It does so many things that the TI-84 can't do, and it does them easier. So anyways, if on my big calculator, when I typed the square root of 153, it gave me a decimal answer, which is something I wouldn't want. If a problem doesn't have a decimal in it to start, probably wouldn't want a decimal answer. On this calculator, if I actually turn it on, and I type the square root of 153 and hit enter, it magically gives me that 3 square root of 17. I got this calculator at Walmart, not that I'm trying to push that store, and it's under $20. It's probably $17 or $18. It's a really great calculator. If you have the money and the desire to pick this up, it could hardly hurt. You can use it on any test, and one of the big things it does is it reduces square roots nicely. It also does computations with eyes perfectly well as well. All right, so that's way overkill on problem 2, but probably needed to be done. Do the same thing for problem 4. I'm going to plot the points. I think I'm going to make this, or this will be a nicer problem in terms of the C. The distance between the points isn't going to be such an ugly number. So I'm plotting the first point, which is the point -3, 5. The second point, which is the point -1, 1. The distance I'm trying to find is this distance. For me, the easiest way to do it is just to draw a nice triangle. So I draw a line parallel to the x-axis and then parallel to the y-axis and make a triangle. I'm going to label this point right here. This point is the point -3, 1. I'm going to call the sides letters. The first side that's parallel to the x-axis I'm going to call A. The side parallel to the y-axis I'm going to call B. And the length that I'm searching for I'm going to call C. To figure out what A is, the A is the distance of this line segment. I can see that that's just 2 units long, but technically to find A, I'm just going to subtract the x-coordinate of the given point, -1, 1, minus the created point, -3. The x-coordinate of that is -3. If I do this subtraction, I have a double negative, which I turn to a positive, and I'm going to get a 2. So one of the lengths I'm going to need when I do my Pythagorean theorem is a 2. The other length I'm going to need is the b, which is this distance, and the b is going to be the difference between the y-coordinate of the given point and the y-coordinate of my created point in my triangle. So it's going to be 5 minus 1, which is going to be 4. And again, you probably could have just counted and got this. So now I'm going to use the Pythagorean theorem, a squared plus b squared equals to c squared. And I'm going to go a squared plus b squared equals c squared. The a squared is going to be 2 squared. The b squared is going to be 4 squared. The c squared is what I'm trying to find. 2 squared is 4. 4 squared is 16. 4 plus 16 is 20. So I get 20 equal to c squared. Solve by square rooting. I don't need plus or minus for the square root because the c represents a length, and lengths aren't negative numbers. Square root the right side. The square root cancels out the square, leaves me with the c. I don't know the square root of 20. On this calculator, if I type square root of 20, calculator tells me that's 4.47. The problem didn't start with decimals, so I don't want that answer. The answer I'm going to want, if I do square root of 20 on this calculator, it's 2 square root of 5. So the distance between the 2 points is the answer, is going to be 2 square root of 5 units. To get that 2 square root of 5 without my calculator, I would have had to take the 20, or the square root of 20, and think of it as the square root of 4 times the square root of 5, because 4 times 5 is 20, and 4 is a number I know the square root of. So the best answer for problem 4 is the distance between the points is 2 square root of 5. When I write my answer key, I would probably just write that number 2 square root of 5 and not do it, write the words with my answer. Ultimately, there's a formula that can get me the answer. I'm going to revisit number 4 and show you how to get the exact same answer using something called the distance formula. So I'm going to do number 4. I rarely do a problem 2 ways, but this second way it's important, and we're probably going to need it in the next section. So I know the answer. The distance between these 2 points is 2 square root of 5. I solved it using the triangle method. Now I'm going to solve this using the distance formula. It's going to give me exactly the same answer. I don't know that it's easier or harder, but for me, the triangle way is the easy way. The distance formula, you have to remember it if you're going to use this way. D stands for the distance between the 2 points. And I get the distance between the 2 points by doing this. Take the x-coordinate of the second point, which is x sub 2, minus the x-coordinate of the first point, square that result, and then plus, all under a square root, the y-coordinate of the second point, which I'm going to call y2, minus the y-coordinate of the first point, which I'm going to call y1, and I'm going to square that. So, to solve this using the distance formula, I need values for x1, x2, y1, and y2. In this particular problem, the first point, negative 3, 5, its x-coordinate is negative 3, its y-coordinate is 5. So in the formula, for x1, I'm going to put the number negative 3 because it's the x-coordinate of the first point. For y1, I'm going to put 5 because it's the y-coordinate of the first point. And for x2, I'm going to plug negative 1 in for it. And for y2, I'm going to plug 1 in for it because x2 is the x-coordinate of the second point, y2 is the y-coordinate of the first point. So if I take those 4 numbers and plug them into the formula, I'll get the distance between the 2 points is x2, which is negative 1, minus x1, which is negative 3. Because I have 2 minus signs next to each other, I'm using a parentheses for the negative 3, squared, plus y2, which is 1, minus y1, which is 5, squared, all under a square root symbol. Now I'm going to get the numbers under the parentheses simplified. The first parentheses, I have a double negative. That double negative I'm going to make positive, and I'm going to get negative 1 plus 3. And that first parentheses is going to come out to be 2 squared. The second parentheses, 1 minus 5, is going to be negative 4. So I'm going to write plus negative 4 squared. Now I'm going to do, so I did parentheses first, now I'm going to do exponents. First exponent, 2 squared is a 4. Second exponent, negative 4 squared is negative 4 times negative 4, which is positive 16. So this gives me the square root of 4 plus 16. So the distance between the 2 points is the square root of 20. If you left that for an answer, that would be a minus 1. If you gave me the decimal version of that answer, I'd probably make a minus 1. The best thing to do at this point is either with your calculator or with some technology, simplify that radical. So 2 square root of 5 is the distance between the points. Okay, 6 is the same style of problem. Wants me to find the distance between the 2 points. And I'm going to just use the distance formula because ultimately I'm going to need that in the next section. So I'm going to find the distance between the 2 points using the distance formula. Again, I'll write it down just so you can have it memorized. Turns out that it doesn't matter if I write x2 minus x1 or if I write x1 minus x2, but I'll be consistent with myself at least. I'm going to go, the distance formula is going to be used to compute the distance between these 2 points. I could get the distance between these 2 points using the triangle method, If I'm using the distance formula, I need to have values. I'm going to write x1 is going to be 5. It's the x-coordinate of the first point. y1 is going to be 1. It's the y-coordinate of the first point. x2 is also going to be 5. It's the x-coordinate of the second point. And y2 is going to be 2, the y-coordinate of the second point. Plug the numbers into the formula. I get the square root of x2 minus x1, which is 5 minus 5 squared, plus the square root of y2 minus y1, which is 2 minus 1 squared. This gives me the square root of 0 squared plus 1 squared, because the first parenthesis 5 minus 5 is 0. The second parenthesis 2 minus 1 is 1. 0 squared is 0 times 0, which is 0. 1 squared is 1 times 1, which is 1. 0 plus 1 is 1, and break out my calculator. I know how to do the square root of 1 in my head, but just in case you don't know, the square root of 1 is just 1, and the radical goes away. I don't do a plus or minus here when I'm doing the square root, so I get d equal to 1. The answer, the distance between these 2 points, is 1. That would be the perfect answer for this. This problem would have been kind of tricky to do with the triangle. In fact, I couldn't have probably drawn a triangle. It's just, so I introduced the formula when it probably was really needed. And just to save time, I won't do the triangle method, but both strategies will work just fine. And I'll just leave this there. But the distance formula, it's a semi-big deal in calculus, and it comes up again in the next section, so it's good to have this down. So the distance is what we did for the first 6 problems, or 3 of the first 6 problems. The next group of problems ask similar instructions. They want me to plot these points on a graph. It would be nice if I had a nicer graph to fit this point, but I don't. Let me go with it. So what these problems are asking me to do is something different. It says plot the points on the graph, so I'll go ahead and do that. So the first point is the point 1, 2. Easy enough to plot that on the graph. The second point is the point 4, 14. Again, I'm kind of going to fudge and not do this so perfectly. I'm estimating my 14. And here's the point 4, 14. So I've done this part. I've plotted the points on the graph. And it says then, it should say then find the midpoint of the line segment that connects the points. So what I'm supposed to do is connect the points with a line segment. Don't need to draw any triangles. What I need to do is split the line into 2 equal halves. That's about equal. I need to find the coordinates of that point. And if I look at this, it's going to be hard to tell from my graph because my graph just isn't that accurate. So I'm going to be bound to a formula. It looks to me like when I drew this, oh gosh, it looks like 2, but it really isn't 2. So how do I find the coordinates of this point accurately, especially if my graph isn't that accurate? In order to answer this question accurately without graphing paper, is going to be hard. Let me just do it via the formula. So I'm going to use a formula approach. The midpoint is a point, so it has both an x and a y coordinate. So I'm looking for 2 different numbers. I'm trying to find the coordinates of the point that is in the middle of this line segment. Every point has both an x and a y. To get the x coordinate of the midpoint, I just add up the x coordinates and divide by 2. The formula for the x coordinate of the midpoint is the x coordinate of the first point plus the x coordinate of the second point divided by 2. So I'll do that real quickly. The x coordinate of this midpoint, I take the x coordinate of the first point, which is 1, plus the x coordinate of the second point, which is 2, and divide by 2. This gives me 5 over 2, which is 2.5. I could write 5 over 2. I could write 2.5. I could write 2.5. Because the problem didn't have decimals, probably I won't write a decimal answer. It doesn't matter which of these I write, but I'm going to write 2.5 as a mixed fraction. So this point right here, that point that I drew, the x-coordinate is supposed to be at 2.5. To get the y-coordinate of the midpoint, which is the rest of the answer, I'm going to do something similar. I'm going to add up the y-coordinates of the points and divide by 2. So there's 2 computations to get the midpoint because it has both an x and a y coordinate. The y coordinate, I'm going to take the y of the first point, which is 2, plus the y of the second point, which is 4, and divide by 2. This is going to give me 16 over 2, which is going to be 8. So this point, if I drew it on graph paper, would be the point 2.5 comma 8. So the answer to number 8, the midpoint, the coordinates of the point that's halfway between on the line segment that connects the given points is 2.5, which you could write as 5/2, comma 8. Generally, I don't like mixed fractions, but here just the mixed fractions seem to make sense. So each of the problems between 7 and 12 is just going to be a matter of doing exactly what I did. I'm going to draw the graph just so I can kind of gauge whether my answer is reasonable. This, even though I haven't incremented the y-axis, that looks reasonable to be 8, and this looks reasonable to be 2.5. So 2.5, 8 does seem like a reasonable answer. And the graph I'm not really going to use to get my answer, but I'm going to use to check how reasonable my answer is. So same deal for number 10. And number 10, I could maybe do a better job because I have graph paper here and these points will fit. So I'm going to do problem 10 and show you how reasonable my answer is. So I'm going to plot the first point, which is the point -3 comma 5. And you don't need graph paper to do this. Actually, you don't even need to graph to do this. Second point is -1, 1. I'm going to draw. I'm going to connect the points. So I've graphed the points, I connected it, and if I had to guess, it looks like this point right there would divide that line into 2 equal segments. Because I'm using graph paper and because I think the answer doesn't have any fractions, I think the midpoint, the middle of the line segment that connects those 2 points, is going to be the point -2, +3. That's what it looks like anyways, but I'll confirm it using a bit of algebra. How do I get it? Via algebra, first I do the x-coordinate. To find the x-coordinate of the midpoint, you take the x-coordinate of the first point plus the x-coordinate of the second point divided by 2. The x-coordinate of the first point is -3, the x-coordinate of the second point is -1. When I'm doing the addition here, when I'm adding 2 negative numbers, they stay negative. So I get -4 over 2, and that'll give me -2. Let me do another plug for this calculator. This calculator does fractions awesomely. If I wanted to do this computation on my calculator, I'd hit the fraction button. In the numerator, I'd hit the negative sign. I'd go -3 plus -1. Use my down arrow. The denominator, I'd put 2. So I can make this problem look just like that problem. And when I hit enter, it tells me that -2 is the x-coordinate of the midpoint. This calculator is so nice in that I can almost enter any problem just how it looks, which I can't really do on my big calculators. Now I'm going to do the y-coordinate of the midpoint. To do that, I'll take the y-coordinate of the first point, which is 5, plus the y-coordinate of the second point, which is 1, divide by 2. This gives me 6 over 2, which is 3. So the answer that I guess from my graph is correct. The midpoint of the line segment that connects those 2 points is the point -2, 3. The whole answer to number 10, you just have to write -2, 3. This is an easier problem, I think. So I'll do 12. And again, I probably can do 12 via graph paper because, well, could if I had nice graph paper, but I don't. Let me go back to the last one. Can I sneak that on there? Yeah, I'm doing minus graph paper because the graph paper that I had wasn't incremented the same way on the x-axis. Let me plot the points then. So the first point is the point 5, 1. So I go right 5 and up 1. That's the point 5, 1. The second point is the point 5, 2. The line segment that connects those 2 points is there. The point that I'm trying to find the coordinates of that point right there. That's the midpoint of that line segment. And you might be able to do that by, even with my crude graph drawn without graph paper, you might be able to know the coordinates of that point. I think that's the point 5, 1.5. It definitely has an x coordinate of 5. And I think, so my guess is that this point right there has the coordinates as 5 and then 1.5. But let me confirm that. So to do the midpoint via algebra, I find the x coordinate first. To find the x coordinate, I take the x coordinate of the midpoint, I take the x coordinate of the first point, plus the x coordinate of the second point, divide by 2. 5 plus 5 over 2 is 10 over 2, which is 5. So in my answer, the x coordinate of the midpoint is 5. When I go to do the y coordinate, I'm going to do the formula. I'm going to take the y coordinate of the first point plus the y coordinate of the second point divided by 2. This is going to give me 3 over 2. 3 over 2 is 1.5, or it is 1.5. You can write 5, 3 halves. I'd be content with that. You can write 5, 1.5. I'd be content with that. If you wrote 5, 1.5, I'd be content with that. But usually if a problem doesn't start with decimals, you just don't insert decimals. All right, so that's that bank of problems. Next bank of problems, I probably can do something nice with graphing, but I'm going to try to speed up this so it doesn't drag on forever. In order to find the slope of the line that connects 2 points, I'm going to use the formula, the slope formula that hopefully you have some remembrance of, and that formula is going to be y2 minus y1 over x2 minus x1. For each of the problems between 13 and 20, I'm trying to find a single number that measures the steepness of the line that connects the 2 points. I've drawn those points a few times now. I could actually find one of the times I drew those 2 points. So I drew those there. So I'm trying to find the measurement of the steepness of this line. That's a fairly steep line. As I move this line, as it goes from left to right, goes up. The number that measures the steepness of this line is going to be a positive number, because as I move from left to right, the graph is going up. If I was finding the slope of that line, it would be a negative number, because on this line, as I'm moving from left to right, it's going down. So immediately, I know that, since I have the points plotted already, that the number that I get for the slope needs to be a positive number because the line has positive slope. I need to have values for each of the numbers in the formula. The x1 is going to be the x coordinate of the first point, which is 1. The y1 is going to be the y coordinate of the first point, which is 2. The x2 is going to be the x coordinate of the second point, which is 4. The y2 is the y coordinate of the second point, which is 14. We'll plug those 4 numbers into the formula. I'm going to go m equals, and in place of y2, I'm going to put the number 14. Then I'm going to put a minus sign. In place of the y1, I'm going to put the number 2. In the denominator, in place of the number x2, I'm going to plug a 4. I'm going to have the minus sign from the formula, and in place of the x1, I'm going to put a 1. Do my algebra here. 14 minus 2 is 12. 4 minus 1 is 3. I'm using m for slope, but I could write the word slope. And 12 over 3 is 4. So the answer to problem 14, the slope of that line that I drew was 4. Probably do some nice things to illustrate the slope, but I'll get that in a second when I do some graphing. So for now, I'll just do completely algebra formulas just to save some time. 16 wants me to find the slope of the line connecting these 2 points again. So I need to have values for x1, y1, x2, and y2. I'm going to use the same formula. The slope of the line that connects those 2 points can be found by using the formula y2 minus y1 over x2 minus x1. Into that formula for y2, I'm going to plug 1. For y1, I'm going to plug 5. For x2, I'm going to plug -1. For x1, I'm going to plug -3. In the denominator, I have a double negative. Usually when you have a double negative, you capture that second negative in a parentheses just to make it pop. You don't really need to have it, but it's nice to see it there. Show you this calculator. Again, this calculator is just completely awesome. I can enter this on my calculator. Hit the fraction button and go 1 minus 5 for the numerator, and then go down low and go -1 minus, and I don't even need a parentheses, but I'll put it in, -3. So again, one of the beautiful things about this calculator is I can make problems look just like they need to look, and when I hit enter, it tells me this whole thing should be -2. So my answer for this question, the slope of the line that connects those 2 points, is going to be -2. And I was able to enter this without really doing anything too complex. But without my calculator, the numerator, 1 minus 5 is -4. The denominator, I have a double negative, which I'm going to turn to a plus. The denominator is going to turn into -1 plus 3. -1 plus 3 is +2. -4 over 2 is going to be -2. So the answer to problem 16 is -2. I think we're going to get to some zeros. It's going to be important that you know about fractions with zeros. So just a quick review of this before I jump into 18 to make you remember this. A fraction with a 0 in the numerator. It doesn't equal undefined, it actually equals 0. For instance, this fraction, 0 over 6, if I did that on the smoking calculator, did 0 over 6, my calculator would tell me that equals to 0. Similarly, if I had 0 over -3, fraction 0 over -3 also equals 0. So any fraction with a 0 in the numerator is equal to 0. Fraction with a 0 in the denominators are undefined. So if either of those fractions were flipped, if I would have done 6 over 0, did fraction 6 over 0 and hit enter, it's going to give me some sort of error, math error, can't divide by 0. So this we'll say is undefined. Similarly, if I did -3 over 0, that's also going to be undefined. So when I'm doing slope computations and I get zeros, depends where the 0 is, what my answer is going to be. So for problem 18 and problem 20, I'm asked to find the slope of the line. I need to have a value for x1, y1, x2, and y2. I'm going to use the slope formula, which is y2 minus y1 over x2 minus x1. For this particular problem, y2 minus y1 is going to be 2 minus 1. x2 minus x1 is going to be 5 minus 5. When I do this, I'm going to get 1 over 0. The correct answer for the slope of the line that connects those 2 points is undefined. It's going to be a vertical line, actually. If you wrote 1 over 0 in for your answer blank, I'd probably take a point off because that's not the best answer that you could possibly write. 20 is going to be similar. Same deal. I'm going to pick a value for x1, y1, x2, and y2. Plug the numbers into the formula. In the numerator, y2 minus y1, which is going to be 2 minus 2. In the denominator, x2, which is -7, minus x1, which is 6. Simplify the numerator. 2 minus 2 is 0. In the denominator, both the numbers 7 and 6 are negative. I'm going to add them and keep them negative. I get a 0, so I know my answer is either going to be 0 or undefined. And the slope of the line that connects those points is going to be 0 because it's a fraction that has a 0 in the numerator. All right. Sketch a graph, label at least 4 points. So each of the problems between 21 and 30, it's written in slope-intercept form. When I look at problem 22, the equation is solved for y, and to the right of the equal sign, I see a number times x plus or minus a number. This is considered slope-intercept form. The number in front of the x is the slope. The constant after the x is the y-intercept, or at least where the number where the graph crosses the y-axis. So to graph this, what I'm going to do, didn't bring enough graph paper. To graph this, I'm going to go get some graph paper because I want to do a better graph than I can do without graph paper. So again, I'm going to leave. I was apparently just not prepared this morning, and I'll be back in a minute. Sorry for that horrible delay, but I can do a way better graph with graph paper. And hopefully this graph paper will be suitable. So I'm going to graph this line, which was y equals to 1/4 x minus 2, by doing first plotting the y-intercept. So I'm going to plot -2, which is the y-intercept, on the y-axis. And now I'm going to use the slope. The numerator of the slope is the y direction. Since it's positive, I'm going to go up. The denominator of the slope is the x direction. Because it's positive, I'm going to go right. So from that point, -2, comma, or the point on the, from the y-intercept point 0, -2, I'm going to go up 1, right 4. So up 1, right 1, 2, 3, 4. Get to another point on the graph, which is going to be the point 4, -1. I'm going to do this again. I'm going to go up 1 and right 1, 2, 3, 4. Takes me to the point 8, 0. I said label at least 4 points. I'd like to go up 1 again and over 4 again to the point 12 comma 1, but I can't because I'm out of room. So I can do the opposite. Instead of doing up and right, I could go down and left. So the alternative would be to think of the slope as -1 over -4, which is the same thing as positive 1/4. And that would cause me to go 1 down and 4 left. So I'm going to go 1 down and 1, 2, 3, 4 to the left. That points to point -4, -3. And now I'm going to connect all the points that I drew with a line that actually goes through the points. And this would be what I'm searching for here. So the equation was solved for y, was a nice y equals mx plus b form. You can graph any equation really quickly in y equals mx plus b form by plotting the y-intercept and using the slope to get additional points. I'll do a handful of these. It was 22. And now let me go to 24, which is a little bit tricky. 24, I don't see a b. I have to think of 24 as y equals to 1/4 x plus 0. If there's no number after there's no b, the b is 0. And I'm going to start off problem 24 by plotting the b, and the b is 0. So in this particular case, the y-intercept, or at least the b, is 0. The slope is the same. The numerator is the y direction. The denominator is the x direction. Because they're positive, I'm going to go in the positive direction. So from this point, I go up 1 and then right 1, 2, 3, 4. Takes me to the point 4 comma 1. And then again, if I go up 1, right 1, 2, 3, 4, that's going to take me to the point 8, 2. That's only 3 points. I asked for 4, so I'm going to do the other version of the slope, which is an odd version, but I can change both the signs. -1 over -4 is still 1/4, and I can go down 1, left 4. So if I go down 1, left 1, 2, 3, 4, I end up at the point -4, -1. All those points should fit on the same line. If you get a point that's way off, then you made a mistake somewheres. And that's what's asked for in problem 24. I sketched a graph and I labeled 4 points. You don't have to have the same points as me labeled, but it kind of makes sense because those are the points that come out from the formula. 26 is going to be hard to fit, and I might not give you the full 4 points. For 26, the slope is the number in front of the x. The y-intercept, or what I'm going to plot on the y-axis, is 1. This slope isn't helpful. It's not a fraction. I'm going to change the slope to a fraction. I'm going to write it as 6 over 1. And what I'm going to do then, from each point, I'm going to go up 6 and write 1. So if a slope isn't a fraction, you do need, if you're using this strategy, the slope to be a fraction, and I'm going to make it a fraction by just kind of forcing a 1 in the denominator. So I'm going to start off by plotting 1 on my x-axis. I'm going to go up 6. 1, 2, 3, 4, 5, 6. Write 1. I'd like to go up 6 and write 1 again, but I can't. The alternative would be to go down 6 and left 1. So let me do that. 1, 2, 3, 4, 5, 6, and left 1. I'd like to be able to do that again. 1, 2, 3, 4, 5, 6, and left 1, but I really can't. Let me just live with 3 points here. The points are off of my graph if I try to draw 4 points, but this is reasonable. I just 4, I just picked that number just because I want you to be able to do more than 2 points. And you can do that by going up and right or left and down for these last 3 problems. Should have probably had a negative slope. I think I'm going to get one here. So 28 and 30, if I wanted to do the same strategy, I have to have the equation solved for y, because to do the y equals mx plus b strategy, the equation needs to be solved for y, so I put that as a hint here. So I want to graph these and label 4 points. And in order to get a reasonable graph, have to have the equation solved for y if I'm going to use this graphing strategy. To solve this equation for y, I can subtract 4x from both sides and then divide everything by 5. If I did that, I'd get the equation y equals to negative 4/5 x minus 2. So for this problem, the slope is going to be negative 4/5. And what that's going to tell me to do, it's going to tell me to go down 2, down 4, and go right 5. The y-intercept is going to be at negative 2. So what I'm going to do is I'm going to plot negative 2 on the y-axis, and then I'm going to go down 4 and right 5. I'm probably going to be out of room. To get an extra point, I'm going to do the opposite of going down and right. I'm going to go up and left. So to do this problem, I'm going to plot the point negative 2. So there's my y-intercept. And then it says to go down because the numerator is negative, and that's the y direction. So I'm going to go down 4 and right 5. That takes me to the point 5, negative 6. I can't go down and right again, so I'm going to do the opposite on each one of these. I'm going to go up and left, and that will also work. So going up 1, 2, 3, 4, and left 1, 2, 3, 4, 5 will still get me a point on the graph. That point's going to be the point negative 5, comma 2. All these points should line up on a line. If they don't line up on a line, then you've messed up. It's only 3 points. I asked for 4 points. I don't think I could do that again. If I went up 4 and left 5, I'd still get off my screen. So I'm going to live with 3 points here and violate what I asked for. I asked for 4 points. I gave 3 points. If this was a test question, I'd give you a graph that can accommodate the number of points that I'm asking for. 30, same strategy. I'm going to solve the equation for y first before I do my graph. To solve this equation for y, I'm going to minus 5x from both sides. When I do that, I get negative 2y equals negative 5x. Then I'm going to divide both sides by negative 2. On the left side, I'm left with the y. On the right side, the two negatives cancel and become positive. And I get y equal 5/2 x. So the slope for this particular problem is 5/2. So I'm going to go up 5 and right 2. I don't see a y-intercept because there's no number after the x, so the y-intercept is going to be 0 because I have to think of this as y equals the 5/2 x plus 0. So I'm going to plot 0 on the y-axis and then go up 5 and right 2 as many times as I can. So for this graph, I plot 0, which was my y-intercept, and then I go up 5, 1, 2, 3, 4, 5, right 2. So going up 5 and right 2 is a nice thing to do. I'd like to go up 5 and right 2 again, but I'd get off my graph. So I'm going to do the opposite of each. Instead of going up, I'm going to go down. And instead of going right, I'm going to go left. So from this point that I started at the origin, if I went down 5, 1, 2, 3, 4, 5, and left 2, I'd still get another point on the graph. So the points that I'm going to have, I have the point 2, 5. The origin is the point 0, 0. This point's the point negative 2, negative 5. And again, if I went down 5 and left 2 again, I'm going to be off my graph. So I'm just going to do less than I've asked for. I'm going to do 3 points. Again, you can tell if you've messed up because if you find more than 2 points and the points all don't line up on the line, then one of your points is wrong, or maybe 2 of your points are wrong. So that's that bank of problems. There really wasn't a lot of algebra in there, but there's a little bit. The next problems it says 31 through 38, find the x and the y-intercepts and sketch a graph. And I'm going to live dangerously. It says it's enough to label just 2 points on your graph. And so that's what I'm going to do. I'm just not going to go for the 3 or 4 points graphs. And because I'm asked to find the intercepts, I'm not going to write the equation in y equals mx plus b form and graph like I did the last few problems. I'm going to graph completely differently. And these problems require algebra. It's not hard algebra. We did x-intercepts in the last section, and we did y-intercepts as well. To find the x-intercept, I plug 0 in for y and solve for x. So when I do that, I get 3x plus 0 equals to 15. That leads me to 3x equals to 15. That's going to give me x equal to 5. So technically, the x-intercept for this graph, where this graph is going to cross the x-axis, is going to be at the point 5, 0. The y-intercept, I plug 0 in for x and solve for y, so I'll go 3 times 0 plus y equals to 15. This gives me 0 plus y equals to 15. That gives me y equal to 15. So the y-intercept for this, since it's a point on the graph, it has both an x and a y. It's the point 0, 15. So I've done the first half of the instructions. I found the x and the y-intercepts. Have 2 points. 2 points is the minimum to get a line. So I'm going to plot the point 0, 15. I'm going to cheat on the y-axis. I'm going to increment it by 5, because to increment by 1 to get to 15 would seem kind of ridiculous. So there's the point, the y-intercept, 0, 15. Do the same thing on the x-axis. I'm going to increment by 5. Here's my x-intercept, which is the point 5, 0. I said it's enough to label 2 points. I have 2 points labeled. I'm going to draw a line through those 2 points. I'm going to call that my answer. So that would be a perfect graph for 32. A lot of times I get lazy. I draw my lines without arrows. It probably wouldn't be bad to put arrows at the end of your lines, because the lines go on forever and they don't end. That's all that 32 wants. It was pretty clean math, no fractions to plot, no negative numbers. It was as clean as we can get. 34 similarly is going to be clean, but I'm going to have some negatives to deal with. I'm going to get some decimals or fractions to plot as well. So I'm going to find the intercepts, because that's required. The x-intercept I get by plugging in 0 for y. To do that, I'll get 3x minus 6 times 0 equals to 9. 6 times 0 is 0, so when I plug 0 in for the y, I get 3x equals to 9. I divide by 3. And part of the answer to this problem, because it asks me to find the x-intercept. The x-intercept is the point 3, 0. To do the y-intercept, I'm going to plug 0 in for x. I'm going to go 3 times 0 minus 6y equals to 9. That gives me 0 minus 6y equals to 9, which gives me minus 6y equals to 9. Have to divide both sides by negative 6. On the left side, I get a nice y. On the right side, I get a negative, because a positive divided by a negative is a negative. It looks odd to keep that negative in the denominator. I'm going to move it up to the right of the fraction. And 9 over 6 reduces by 3 to 3/2. So I'm going to write y equal to negative 1 and 1/2. So that's what 3/2 is a fraction. So the y-intercept is the point 0, comma, negative 1 1/2. I'm just going to plot the points and connect them. So on my x-axis, I need to have 3. So my x-intercept is the point 3, 0. On my y-axis, I need to have negative 1 1/2. So negative 1 1/2, I'm going to estimate it at somewhere between negative 1 and 2. So I've plotted my x and my y-intercepts. That's enough. I'm just going to connect the graph with a line segment, and that would be perfect. This is a good strategy. The only danger is you can't tell if you've made a mistake, because you only have 2 points. If you were plotting 3 or 4 points, if one of the points wasn't fitting on the line, then you knew you had a mistake someplace. Here, I'm not sure that I don't have a mistake, but it's a quick way to do it, and it's a real common way to do it, so it's not a bad way. 36 is a mess. I don't want to deal with these fractions. So because the problem has an equal sign, I can tweak the problem before I get into it, and I should definitely do that. So before I start finding the x and the y-intercepts, I can transform the equation so that it no longer has fractions, and doing this isn't going to alter the x or the y-intercepts. So I didn't want to work with those fractions. I looked at the two denominators, 3 and 2. The least common denominator between 3 and 2 is 6. If I multiply every fraction by 6, along with the 5, I'm going to get a problem that doesn't have fractions that has the same x and y-intercepts. First thing, when I multiply by 6, I'm going to cancel with the 3. I'm going to be left with a 2. I'm going to multiply those 2's together and get a 4x. Second time, I'm going to cancel the 6 with the 2 and get a 3. Fraction will be gone. Leave my minus sign. I'm left with 3 times 1, which is 3y. To the right of the equal sign, nothing cancels. I get a 30. It's a messy, messy problem. I'm going to get fractions. I had fractions to start. I'm going to get fraction intercepts. But it's just the reality. Math starts to get grungier the higher you get in math. So this just kind of is what it is. So now I'm going to find the intercepts. So transforming the problem so it doesn't have fractions is probably the sanest thing to do, because this problem without the fractions has the same intercepts as the initial problem, and it has the same graph as well. For the x-intercept, I plugged in 0 for the y, and I get x as 30 over 4. 30 over 4 reduces to 15 over 2, and 15 over 2 is 7.5. So when I go to graph this, for my x-intercept, I'm going to graph 7.5 on the x-axis. For the y-intercept, I'm going to go 4 times 0 minus 3y equals to 30. This whole piece is going to zero out. It's going to leave me with minus 3y equals to 30. I'll divide both sides by negative 3. And I'm going to get y equals to negative 10. So for the y-intercept, it's going to be the point 0, negative 10. So now I have my points that need to be plotted. I don't really need graph paper, but I don't feel like drawing a graph to fit this. So let me plot those 2 points. I need the y-intercept to be negative 10. So I'm plotting negative 10 on a y-axis. Your graph doesn't have to be this accurate. And then the x-intercept is 15 over 2, which is 7.5. So I find 7.5 on the x-axis. And I'm just going to connect those 2 points, to something that looks like a line. It'd be nice if I threw arrows at the end of my line. So that would be the finishing part of this. Again, you can do whatever you want with your graph. You could have incremented the y-axis by 2 just to speed up the process, but just plotting those points and connecting them with something that's reasonably accurate. 38, I've got the same issue. I've got these nasty fractions that I don't want to deal with. I'm going to just go through and multiply. By 7 to get rid of the fractions. If you're comfortable working with fractions, then don't do this. But I make more mistakes working with fractions than non-fractions. If a problem has fractions and an equal sign, you can multiply a way to get rid of the fractions. And now I'm just multiplying everything by 7. First canceling will leave me with a 2x. The next multiplying by 7 will leave me with a 7y. To the right of the equal sign, I get a 28. This version of the original problem will have the same intercepts and the same graph. And for me, it's a lot easier to work with a problem without fractions than it is a problem with fractions. So now I'm going to find my intercepts. My x-intercept, I'm going to plug a 0 in for y. I'm going to go 2x minus 7 times 0 equals 28. This piece will zero out. ultimately it will leave me with 2x equals to 28. My x-intercept is going to be 14. So in my answer, I'm going to say the x-intercept is the point 14 comma 0. And then I'll do similar for the y-intercept. I'll plug 0 in for x. I'll go 2 times 0 right into that equation. Minus 7y equals to 28. This piece zeroes out. It leaves me with minus 7y equals to 28. Divide both sides by a negative 7. I'm left with a y on the left side. On the right side, positive divided by negative is going to give me a negative, and that reduces to negative 4. So my y-intercept is going to be the point 0, negative 4. I'm going to do a real horrible graph, but I'm going to live with it. To graph this, I need to find 14 on the x-axis. I'm just going to pretend and say that that's 14. I need to find negative 4 on the y-axis. And again, I'm going to do very crudely. I'm going to say that's about negative 4 on the y-axis. And I'm going to connect with something that actually goes through draw a thick enough line segment, and it'll look like it goes through even when it didn't really. And that would be the most primitive graph you can do. But you can draw a really nice graph if you mark out 14 little tick marks on the x-axis and 4 on the y-axis, and do a picture that's suitable. Okay, that's finally out of that bank of problems. Now we're into the finding equation problems. And all of the finding equation problems can be done a couple ways. I'm going to do them all one way. And I'm going to use the formula y equals mx plus b to help me get my answer to every single problem. I was just peeking to make sure my video hadn't shut off. So my goal here for each of the problems between 39 and 56, my answer between every problem between 39 and 56 needs to look like an equation of a line. My answer needs to be y equals mx in the form y equals mx plus b, but I need to replace the m and b with numbers that fit the problem. Fit the problem. So when I look at this particular problem number 40, the instructions say to find an equation of a line that has slope of negative 2. So for this particular problem, I can replace the m with negative 2 because that's the slope that fits this criteria. But I can't put the b at 1. A b is the y-coordinate of a point that has 0 in its x-coordinate. That 1 is not a b. I need to find the b to fit this problem by doing algebra. And it's real easy algebra. I'm going to use the equation y equals mx plus b to help me find b. And real specifically, into this equation, I'm going to replace the m with negative 2, the x with negative 4, and the y with 1. Because that's the information that fits this problem. When I do that, I go 1 for y equals negative 2 for m times negative 4 for x plus b. I have an equation with only missing the b. I'll be able to solve this equation for b real quickly. I'm going to do the multiplication on the right-hand side. Negative 2 times negative 4 is positive 8. And I'm going to solve for b by just minusing 8 from both sides. So the b that fits this problem is minus 7. And in my answer, to fit this problem, I can put a negative 7 in for the b and just say the answer, the equation that fits this criteria is y equals negative 2x plus 7. The other way I could do this is write y equals negative 2x minus 7, because plus negative 7 and minus 7 are the same. So for most every problem between 39 and 56, the only thing I'm going to need to do is find the b, because for most of the problems between 39 and 56, the m is given. So I'm going to jump to 42. I'm going to look at the information that's given, decide what I need to find, and write my answer. So for each one of these problems, my goal is to find an equation in the form y equals mx plus b. The algebra is just going to be to find an m and a b that fit the problem. As I read 42, the slope of the line, the m that fits the problem is 1/3. The b that fits the problem, I don't know. So when I go to write my answer, I'm trying to find the equation of the line that fits the data. I know the number that goes in front of the x is 1/3. I don't know the b, so I need to solve for b. I solve for b by taking the values that are given. The 1/3, that's the m. The x coordinate of the point that's given is 12. The y coordinate of the point that's given is -2. I'm going to take those values and plug them into the y equals mx plus b formula. For the y, I'm going to plug -2. For the m, I'm going to plug 1/3. For the x, I'm going to plug 12. I'm going to leave the b alone. This is a friendly problem because 1/3 times 12 doesn't turn into a fraction. For the when you multiply 1/3 times 12, you could cancel the 3 and the 12. The 3 goes away, so the fraction is gone. 12 cancels to a 4. You're left with 1 times 4, which is 4. So this is going to give me -2 equals 4 plus b. Just get a -4 from both sides. And give -6 equal to b. So in my answer, after the 1/3 x, I could either write plus a -6, or I can write -6. If you do a plus and -6, you usually use a parentheses. If you do a -6, you don't. So either one of these would be a correct answer. There isn't one that's more correct than another, although I'd probably generally usually never write plus and negative. It's an extra sign in parentheses that don't really need to be written. Those are friendly-ish problems. 44 is still a friendly-ish problem, but it's different because in 44, I give you the m and I give you the b. In the last two problems, I gave you points that weren't the y-intercept. So the y-coordinate of the point wasn't the b. In this problem, I gave you the y part of the y-intercept, and I gave you the b. 44 has no algebra whatsoever. I give you both the m and the b because the m is the slope, the b is the non-zero part of the y-intercept, so that there's no algebra to do for 44. This equation of this line is just going to be y equals -4x plus -1, or you can write y equals -4x minus 1. It's just a matter of your preference. So it's a trick question because you have to understand when I'm finding an equation for a line, I need both a slope and a y-intercept. And because I have both the slope and the y-intercept, there's no algebra at all to do. 46 is a mess. 46, it gives me the m in hiding. Parallel lines have equal slope. So when I read through problem 46, I'm given an equation for a line, and this equation, y equals 3x minus 2, has a slope of 3. So the slope of the line that I'm trying to find an equation parallel to is 3. Parallel lines have the same slope, so my line needs to be parallel to the line that it's given in the problem. For lines to be parallel, they have to have the same slopes. So my line has to have a slope of 3. So that first little sentence or something to the left of the semicolon helps me get the slope of the line that I'm looking for. And now I'm going to find the b. And what I'm going to do is I'm going to let m equal to 3. I'm going to let x equal to -5. I'm going to let y equal to 1. I'm going to plug them into the formula y equals mx plus b. I'm I'm going to go y equals 1 equals m times negative 5, which is x, plus b. So again, it's just taking the numbers, plugging them into the formula. This is going to give me 1 equals negative 15 plus b. I'm going to add 15 to both sides. On the left side, 1 plus 15 is 16. On the right side, I have my b. And my line b is going to be 16. So my answer, the equation of the line that's parallel to the given line that goes through the point, is going to be y equals to 3x plus 16. So each of the next few problems has the words parallel or perpendicular in an equation of a line. That parallel or perpendicular words is supposed to help you get this m for your answer or your algebra. 48 is almost identical. It's going to be quite a bit messier because it has a fraction and the fraction is going to go away. I'm trying to find a parallel line. Parallel lines have equal slopes. The slope of the given line is negative 2/3 because I'm trying to find a line parallel, and parallel lines have same slopes. My line has to also have a slope that's equal to that of negative 2/3. So when I go to write my answer, because I'm finding an equation of a parallel line, because parallel lines have equal slopes, my line is going to have a negative 2/3 x in the formula. I'm going to find the b. To find the b, I'm going to let m equal to negative 2/3. I'm going to let x equal to 5, y equal to 1. I'm going to plug those numbers into the formula y equals mx plus b. I'll get 1 equals negative 2/3 times 5 plus b. This multiplication, anytime you're multiplying a fraction by an integer, you do that multiplication by just multiplying the numerators. Here the fraction doesn't cancel. I'm just going to multiply the negative 2 and the 5. I called the 5 a numerator because I can think of it as 5 over 1. So this is going to give me 1 equals negative 10/3 plus b. Now it's a matter of what you want to do. If you want to clear the fractions, clear them. So I'm going to do that. I'm going to clear the fractions by multiplying everything by 3. On the right side, if I multiply 1 times 3, I get 3 on the left side, should I say. On the right side, the first multiplication is going to cancel out the 3's and leave me with just a negative 10. Can't forget to put the 3 in front of the b. If I'm clearing fractions, I get a number in front of the b that I don't need, but I have to put it there. To solve this equation for b, I'm going to add 10 to both sides. When I do that, I get 13 equals to 3b. Now I'm going to divide by 3. I'm going to get 13 over 3 equals to b, and I'm going to put that b in my answer. So for all the problems that I'm finding equations of a line, my goal is to get an m and a b that fits the problem, and there's going to be something in the wording that's going to help me get both of those pieces or lead me to the algebra. The next two problems have perpendiculars, and perpendicular lines have slopes that are reciprocals with opposite signs. So perpendicular lines have slopes that are reciprocals with different signs or opposite signs. So my goal is to get an equation for a line that's perpendicular to a line. The given line has a slope of 3, which I can say is 3 over 1. My line has to be perpendicular, so it has to have a slope that has a different sign. This one was positive, my slope needs to be negative, and it needs to be a reciprocal. So my line is going to have a slope that's the reciprocal of that fraction with a different sign. The reciprocal of 3 over 1 is 1/3. Changing the sign from positive to negative is going to give me the correct slope. So because of the word perpendicular, the slope of the given line isn't the slope of my line. Perpendicular lines have slopes that are reciprocals with opposite signs. So in my answer, the number I'm going to put in front of the m is -1/3. Now I need to find the b. I'm going to use m equal to -1/3, x equal to -5, y equal to 1. Plug those numbers into the formula y equals mx plus b and solve for b. So I'm going to go y, which is 1, equals m, which is -1/3, times x, which is -5, plus b. On the right side, I do the multiplication. I multiply the -1 and the -5 and get 5/3. So I'll get 1 equals 5/3 plus b. I'm going to clear the fractions by multiplying by 3. I'm going to go 3 times 1, 3 times 5/3, and 3 times b. 3 times 1 is 3. 3 times 5/3 cancels out the 3's, leaves me with a 5. 3 times b is 3b. So I get 3 equals 5 plus 3b. I'm going to minus 5 and divide by 3. When I minus 5, I get -2 equal to 3b. And I'm going to divide by 3 and get -2/3 equal to b. And I'm going to write that -2/3 in my answer. So the equation of the line that's asked for in problem 50 equals y equals -1/3 x minus 2/3. 52 is the same style of problem. I need to find an m and a b that fits the problem. The original line is going to have a slope, and I'm looking for a perpendicular line. To get the slope of my line, I need to take the reciprocal and change the sign. So the slope of this line is -2/3. My line, because it's going to be perpendicular, has to have a slope that's a reciprocal of that with the opposite signs. So I'm trying to find an equation of a perpendicular line. If I know the slope of the perpendicular line, I know the slope of my line. I get the slope of my line by taking the reciprocal and changing the sign. This sign was negative. I change it to positive. The reciprocal of -3/2, or the reciprocal of 2/3 is 3/2. So my line's going to have the slope of 3/2. Now I need to find its b. To find the b, I'm going to take m equal to 3/2, x equal to 5, y equal to 1, and plug them into the formula y equals mx plus b. When I do that, I get 1 equals 3/2 times 5 plus b. Do this multiplication here, that gives me 15/2. That gives me 1 equals 15/2 plus b. Don't want to work with the fractions, don't need to work with the fractions. When you have a problem with an equal sign and a fraction, you can clear the fractions. Multiply everything by 2. 2 times 1 is 2. To the right of the equal sign, the 2's cancel, make the fraction go away. Leaves me with 2 equals 15 plus 2b. Minus 15 and divide by 2 will take me to where I need to be. 2 minus 15 is -13. This gives me -13 equals to 2b. I'll divide by 2, divide by 2. I get -13 over 2 equals to b. So the answer that I'm going to go for, the equation of the line that I want, needs to have the right m and the right b. And it's going to be y equals 3/2 x minus 13 over 2. So each of the problems up till now, it gave me something so I could get the slope without doing any algebra. The next few problems, I need to do algebra to find the m. So in problem 54, I'm trying to find the slope of my line and the b, and I don't see anything. I wasn't told the slope, nor was I given an equation to find the slope. I need to use the slope formula. So I need to get the slope of my line. And I'm going to use the slope formula to do that. I don't have anything to grab onto in this problem to find the slope, but I do know how to find the slope between 2 points. What I'm going to do is take the first point, 5, 1, and say x1 is 5, y1 is 2. I'm going to take the second point and say x2 is 6, y2 is 3. I'm going to take those 4 numbers, plug them into the slope formula, and get m equals y2 minus y1, which was 3 minus 2, over x2 minus x1, which is 6 minus 5. This is going to give me 1 over 1, which is 1. So the slope of my line is going to be 1. Now I'm going to find the b, and it doesn't matter how I find the b. There's 2 ways to find the b. Let me sneak them in here. I can use m equal to 1, x equal to 5, and y equal to 2, or I could use m equal to 1, x equal to 6, y equal to 3 by using the slope with the second point and still get the same b. So I'm going to use the equation y equals mx plus b. If I plug in 2 for y, 1 for m, 5 for x, I get 2 equals 1 times 5 plus b, which is going to give me 2 equals to 5 plus b. And if I minus 5 from both sides, I get minus 3 equal to b. If I did this other bank of points and did 3 for y equals 1 times 6 plus b, I'd get 3 equal to 6 plus b, and then I'd minus 6 and get minus 3 equal to b. So regardless of the point that you pick, you're going to get the same b, so it doesn't matter which point you pick. You don't need to do both computations. My answer needs to be an equation of a line. The number to the left of the x is the slope. The number after the x is the y-intercept. I don't need to show the 1, but it's not wrong to show the 1. So writing y equal to 1x minus 3 or y equal to x minus 3 is going to be perfect. So that's the end of the non-word problems. There's a few word problems, and both of the word problems are going to have the same strategy. And I'm taking a vote, and I know I'm not going to put these on the test, and this video is getting to be kind of uncomfortably long. I'll write up solutions in my solutions manual for these word problems. I'm not going to do them on the video. I'm not going to put them on the test. If you want to come visit me, I'll do problems 56 and 58 for you. And you also can look in the solutions manual. I'll have the odd problems that are the word problems worked out, and you might be able to parallel the odd and the even problems to get your answer. But these won't be on the test. I won't put them on the review. So just because this is feeling ridiculously long, and I started rushing just to make sure the video didn't run out, I'll just kind of stop there, and you won't be responsible for those word problems. But you will be responsible for everything else in the section. So if there's things that are messing you up, this is a great time to come visit me and let me help you before we get to the test. Especially because I know that lines come up a lot in both brief calculus and regular calculus. So you need to be really good with all the sorts of things that we just did today, because you'll see them again. Even if you'll see them not so much more in this course, but a lot in calculus. So they're important to know. All right, I'm going to shut the video down, and hopefully everything worked perfectly.